Hi friends. So today we are going to see one more question related to the binary search, and this is to find the first occurrence of element k. Okay, so you have given a sorted array, okay, and you have to find the first occurrence of element k, which is a target. Okay, so if I say your target is five, then what is the first occurrence of five? The first occurrence of five is this position. Okay, at the seventh index. So your answer should be seven. Uh, if I say, let me write it down here, k first occurrence. So if k is 5, your first occurrence will be 7. If k is, let's say, minus 6, your first occurrence will be 0. And if k is, let's say, 20 or let's say 30, so you don't have that element inside your array. So you will simply return minus 1. Okay. So what is the idea here? Okay, so the first thing is you can always apply the brute force, and how you can do, you can iterate every element and you will check if that element is found, you will return and you will break, and you will return the answer, right? So this is the brute force, and its time complexity is always O of n. Now, what is the idea to solve this question using binary search? So the binary search is whatever the element you are going to find is either on the left side or on the right side, right? Is either on the, if you are here, if you are here, so your middle element is 5 right now, but your first occurrence is on the left side always. If you are landed on the same element, see, this is the element you are going to search, k is equals to 5. I'm not talking about the brute force yet. If k is equals to 5, you want to search, and if middle element is, you have already landed on the element k, right? So is there any way that your first occurrence is on the right side? Is there? No, right? Either your answer should be this, or it is present on the left side of the middle, right? So either your answer is the middle only, or you have to search on the left side. So if you search on the left side, your H should come before M. Make sense? So this is case one. I've talked about the case one just now. So let me take an example for k is equals to, let's say, 6. Okay. So if your middle element is still at this place, fifth place, sorry, ninth place. Okay. So in this case, my A of M, which is 5, is less than the target. If it is less than target, then my target will be found on the right side of the array of the middle element. I hope you are getting it, because this array is sorted. So this is non-decreasing, and this is non-increasing, or you can say that non-decreasing. This is ascending order. The elements are arranged in ascending order, and you will always find the greater element on the right side. This is the uh, this is the condition here. Now, if your target is greater than the middle element, then you will always search to the right side. And if you search, and this will not be your answer, because target is present on the right side. So this will not consider your answer. So I will search on the right side. M plus one. Make sense? Okay. So this is case two. This is case two. And what is the case three? The case three, if the middle element is greater than target. Let's say if you have to find k is equals to 4. Okay. So if you have to find k is equals to 4, so right now A of M is 5, middle element is 5, and you are greater than the target. So if your target is less than the middle element, then you will search on the left side. And if you search on the left side, you will always place your I to the left of the middle. Okay. And simply at the end, after the loop, we will return the answer. Right. So let me dry run this code. Let me dry run. So this is my L, this is my H, this will be my M, this is the case, this is the search space, and this is an update. What update we are going to do? Okay. So now I'll copy this one. Okay. And let me put this thing here. L L H M case, search space and update. Okay. So right now my L is 0 and my H is 19. Both are at the corner of these of the array. My middle element will be 9 because 0 plus 19 by 2 is 9 and 9 is this element. So in this case, my A of M is 5. And what are we searching right now? Let me search 15 here. So my A of M is, let me search some other value. Mm, let me search 5. K is equals to 5. So my middle element is equals to the K, right? This is case 1. And what will be my searching space? If this is my case 1, if it is equals to the value what we needs to find, then this could be my possible answer, right? Answer is equals to 1. So I can say that my first occurrence of the target could be at the middle because you can see this is equals to the target. Okay. And but this is not necessary that you will always find the target if answer if A of M equals to K. Because you can see here on the left side, one more pipe is present, right? So what I can do, I can search on the left side. So my H will be placed before M. So what is my search space? Left. My search space is left. Now my L will be same 0, but my H is updated to 8, M minus 1. Now the middle value is 4. So right now I am here. Okay. So A of M. What is A of M? A of M is 4. The value is 4. And 4 is less than the target, which is 5. If 4 is less than the target, so my target will always found on the right side. Okay. So I'll search on the right side. And if I search on the right side, I have to place my L after my M and plus 1. Okay. Now my L will be changed here, 5. H remains the same. And this will be 6. And right now my A of M, A of 6. A of 6 is 4. Again less than K. I will again search to the right. And I will move my L to M plus 1. This is 7. This is 8. 7 plus 8 is 15. Divided by 2 is 7. So A of M, what is A of M? A of M is, A of M is, this is the middle element. A of M is 5, and which is equals to the K. So I will update my answer to the M. What is my answer right now? It is 7. And I will search on the left side, right? So my H will be M minus 1. So what is my H? 7. What is my H? H will be 6. So in this case, my L is greater than S. So my while loop break. Okay. And I will return answer, which is 7. Right. So this is it. This is how we can solve this question. Let me write a pseudocode for you. Just a quick one. L equals to 0, H is equals to N minus 1. I will run a while loop, which is L should be less than equals to H. I will populate the M, which is L plus H divided by 2. If I will say A of M equals to the K, which is target, then I will update my answer equals to M and I will search left. Else, if my A of M is less than the target, Then I will search on the right side, L equals to M plus 1. Else, the last condition, which is M, A of M should be greater than. Then I will search on the left side. That's it. And I will simply return answer. And I will let me write initialize the answer to -1. If nothing found, the answer will be -1 will be returned. So the time complexity I'm not going to talk about in this video because this is same as the previous two videos. So you can refer those videos. So this is the solution of this question. Uh, One more question is find the last occurrence. Okay, so this is your to do. Okay, I believe you will do it. So that's it for this video. I'll see you on the next video.